So let's continue talking about vector valued functions, and we're going to continue our discussion. We were going to start talking about the principal unit normal vector and the formula for that, n of t. It's the derivative of our unit tangent vector over the magnitude of the unit tangent vector. So let's look at the following example. Let's find the principal unit normal vector for the vectored valued function 2 cosine ti plus 2 sine tj plus tk. So the first thing you're going to do is find your unit tangent vector. We did that in a previous video, so I'm not going to go over how to find that just for time's sake, but I'll give it to you right here. You should get the following vector: I plus 2 cosine tj plus k. So then, to find your principal unit normal vector, you're going to take the derivative of this. If you take the derivative here, you're going to get minus 2 cosine ti. Take the derivative here, you're going to get a minus 2 sine tj, and the derivative of 1 is just 0. So there's t prime. And then you're going to find the magnitude of this vector. So the magnitude of t prime of t, it'll be this coefficient here that's positive, 1 over the square root of 5. And then I take the square root of negative 2 cosine t squared, negative 2 sine t squared. So here I'm getting 1 over the square root of 5, 4 cosine squared plus 4 sine squared. And if you factor out the 4, you'll be left with cosine squared plus sine squared, which is 1. So I'm left with the square root of 4 over the square root of 5, or 2 over the square root of 5. So then to get our vector n, we're going to take t prime and divide by the magnitude of t prime. And if you do that, your square roots of 5's cancel. So you're going to get 1/2 negative 2 cosine ti minus 2 sine tj, or in the end you'll get negative cosine ti minus sine tj. So there's our principal unit normal vector. So our next topic we're going to look at is arc length. So let's say I have my r of t is x of ti plus y of tj plus z of tk, and then I want to find the arc length when t is between a to b. Well, then the formula for arc length is the integral from a to b of the magnitude of r prime of t dt. All right, so now let's move on to curvature, which will be our last topic in this group. So curvature is represented by a kappa, and there were a couple of different ways to find it. So you could find it in terms of the derivative of your unit tangent vector with respect to arc length. So t prime of s. But usually your unit tangent vector is not in terms of arc length. So another way you can find it is it's the magnitude of r prime cross r double prime over the magnitude of r prime cubed. So let's look at an example here. Let's find the curvature of r of t plus t squared j minus 1/3 t cubed k, I guess, of the curve given by that formula when t equals 1. So I'm going to use this formula back here. So I know I need the derivatives of my function right here, my vector valued function. So find r prime. It's going to be 2I plus 2tj minus t squared k. And then find r double prime. It'll be 0I, so I'll just leave that out, 2j minus 2tk. Now we're done finding derivatives, so you can go ahead and plug in your t value. So here t is 1, so r prime of 1, it's 2I plus 2j minus k. R double prime of 1 is 2j minus 2k. So now we need to find the cross product of these two vectors. So I, j, k, write down the vector r prime first, 2, 2, negative 1, 0, 2, negative 2. So you're going to find this cross product. And if you do, you should get negative 4 minus a negative 2, so plus 2I minus a negative 4j plus a 4k. So you're getting negative 2I plus 4j plus 4k. And then if we go back to our formula, I need the magnitude of this vector. So the magnitude of r prime of 1 cross r double prime of 1 is the square root of negative 2 squared plus 4 squared plus 4 squared. So 4 plus 16 plus 16. The square root of 36, which is 6. And then I'm also going to need the magnitude of r prime of 1. So if you go back, r prime of 1 was this vector right here, 2, 2, and negative 1. 2 squared plus 2 squared plus negative 1 squared. That's going to be 4 plus 4 plus 1. Square root of 9, or 3. So then the curvature was the magnitude of our cross product over the magnitude of r prime cubed. So 6 over 27, or 2 over 9. And that's my curvature right there.